Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to evaluate I to the power I. We're going to look at some interesting stuff, and at the end we're going to check our results with Wolfram Alpha. So I is an imaginary number, as you know, hopefully you do. If not, go ahead and check out the lecture videos. But I is the number whose square equals -1. So we define I squared as -1, and then we basically form complex numbers, writing them as a plus bi, where a and b are real numbers. And a plus bi is also the name of the channel. All right, great. So how do we handle these kinds of things where the base and exponent are both complex numbers? It's kind of like a complex to another complex power. So let's go ahead and talk about that a little bit. First of all, if you have anything like z to the power w, where z and w are both complex, we can basically write it as follows. I can write this as e to the power ln z to the power w, and then bring this w to the front and write it as e to the power w ln z. Actually, we can forget about the step in the middle and directly write this as e to the power w ln z. We got to be a little careful because here the ln z is a complex logarithm. It's not the natural log for real numbers, but it's kind of like a complex logarithm. And we'll probably distinguish between the complex and the real logarithm by using an uppercase ln for the real part. So if you have a complex number like this, for example, let's say z obviously can be written as the absolute value of z times e to the power I theta, but I can also write it as I times arg z. Arg, by the way, represents the argument, which is basically the angle that the z makes with the real axis. Okay, in this case, theta would be the argument of z. And absolute value can also be denoted by r. But I'm just going to use this notation for now. And now, from here, we're going to go ahead and evaluate ln z. When you take the ln, so the left-hand side is going to be the, just the complex logarithm of z, but absolute value of z is a real number all the time, right? So let's go ahead and use an uppercase ln to denote the real logarithm. And then when you ln this one, it's just going to be I times the argument of z. So I can just add it because if you ln a product, it's going to be the sum of two ln's. So now I can write this as I times the argument of z. So we can kind of formulate this, the ln of a complex number, as follows. Okay, of course we do need some requirements. For example, if you wanted to look at the principal value, you can kind of write, usually argument, the arg is written with a capital A, and then the argument z is going to be between -pi and pi. Okay, and when it's on that interval, that's called the principal value. Anyways, let's go ahead and use this. We're going to use this along with this one. Okay? And let's see how that goes. So we do have, obviously, in this case, z and w are both equal to I. So we're talking about I to the power I. Okay? So this can be written as first e to the power I ln I. So we're basically talking about the complex logarithm of I. And guess what? That is multi-valued. Why? Because the argument of z takes infinitely many values, which we'll see in a little bit, right? The principal value is unique, but generally it has, basically the argument is incremented with 2 pi multiples, or n times 2 pi, okay? So let's see how this goes. First of all, we're going to find ln I so that we can plug it in here. And to find ln I, obviously, we're going to use the definition. What was the definition? The ln of the absolute value of I plus I times the argument of I. As you know, I is 0 plus I, so when you graph it, it's going to look like this. And absolute value is going to be 1. And the argument is going to be pi over 2. Great. So that's what we need. So this is going to be 1, and this is going to be pi over 2, right? But guess what? That's just a single value. So in general, I can add 2 pi or multiples of 2 pi to it. So I'm going to write it as pi over 2 plus 2 pi n. So let's find ln I from here. It's going to be the real ln of 1, which is 0, plus I times pi over 2 plus 2 pi n. And if you forget about the 0, you're going to get ln I equals, I times pi over 2 plus 2 pi n. In other words, ln I divided by I is real, but it's multi-valued. Okay? So let's go ahead and plug this into our expression. And that expression was I to the I to the I equals e to the power I ln I. Now we're going to replace ln I with that. So it's going to be another I multiplied by I. And what is I times I? I squared. And what is I squared? Negative 1. So this is going to be negative 1. And now I to the I can be written as e to the power negative pi over 2 plus 2 pi n. What is n? N is an integer. Make sense? Again, this is multi-valued. Depending on the value of n, you're going to get different values, and they are incremented basically by multiples of 2 pi. Make sense? Great. Now what happens if n is equal to 0? You're going to get I to the I equals e to the power negative pi over 2. By the way, hopefully you noticed that I to the I, even though I and I are both imaginary, I to the I is actually real. Okay, that is the real deal. Let's go ahead and take a look at some results from Wolfram Alpha, and we'll basically finish up with that. So I just want to say this is multi-valued, and this is just one of the values of I to the I, which you're going to see on our table. But first, I to the I is a transcendental number, which is a specific or very special class of irrational numbers. So it is irrational, but a very special category. And this is the table that I was talking about from Wolfram Alpha. Notice that for integer values of n, by the way, they just distributed the negative here. That's why you see a little differently. But notice that for n equals 0, for n equals 1, 2, negative values, you do get multiple values for I to the power. So it's not single, it's multi-valued. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.